The final type of a combination of functions is called the composite function. And then we write this as f of g. That's one way to read it. Some people read it as f circle g. Or some people even get lackadaisical with it and call it fog. Okay, fog of x. F of g, and if we're technical, we need of x there. F of g of x is equal to f of g of x. So we're evaluating the function f at whatever g of x is. And the composite function g of f is defined as g of f of x equals g of, parentheses, f of x. So we're putting f of x into g of x. We're combining two functions by actually putting them into one another. All right, so let's look at a couple of examples here. Let f of x equal negative 5x minus 1, and g of x equal x squared plus 5. Find f of g of 7. Now, by definition, f of g of 7 is f of g of 7. Just by definition, that's what it is. F of, and then g of 7. So we're going to go ahead and find, I'm going to do this. Let's find what g of 7 is. I'm going to do this in a couple of stages. G of 7 would be 7 squared plus 5. That would be 49 plus 5, which is 54. So g of 7 is 54. I'm going to replace g of 7 with 54. So this will be f of 54. Now we're going to take the output of putting 7 into g. We're going to take that output and plug it into f. So f is negative 5x minus 1. So put 54 in there. Negative 5 times 54. Negative 270 minus 1 is negative 271. And that's the answer we're after. Let's move on to another example. Given that f of x equals 3x plus 1 and g of x equals x cubed, find f of g of negative 3. Again, I'm going to write this as g of f, or f of g of negative 3. So let's find g of negative 3. That would be negative 3 quantity cubed, which would be negative 27. This in turn becomes f of negative 27. Now let's plug that, or evaluate that, into 3x plus 1. 3 times negative 27 plus 1. 3 times negative 27 is negative 81, plus 1 is negative 80. Always appeal to the definitions as you're working with these. Makes things a little more straightforward. Let f of x equal negative x minus 1 and g of x equal x squared minus 3. Find g of f. Notice the order changed here. G of f of 4. So this, by definition, is g of f of 4. Close all my parentheses. Now let's find f of 4. The order that these are written determines the order that we plug things in first, or we evaluate. So f of 4 would be negative 4 minus 1, which would be negative 5. So let's replace f of 4 with negative 5, and we'll evaluate that value into g of x. That would be x squared minus 3. So negative 5 squared is 25, minus 3 be 22. So our output to that is 22. Last couple of examples, they don't give us an input value. They ask us to find g of f of x and f of g of x. They don't tell us what x is. So what we're going to do is this. G of f of x means g of f of x. Everywhere I have an input for g of x, I'm going to put in my f of x. So my function g of x is 5 times something, let's give more space, 5 times something minus 1. But I am going to insert my f of x into this. F of x is 2x squared plus 2. So now I just need to distribute, combine like terms, and this will be the function that I need. Distributing that would be 10x squared plus 10 minus 1, which would be 10x squared plus 9. That is g of f of x. Now, the next thing we're asked to find is f of g of x. Let's put that over here. F of g of x would be f parentheses g of x, close parentheses. Again, I'm going to take f of x. F of x is 2 times something squared plus 2. And I'm going to input what my g of x is. My g of x is 5x minus 1. All right, so I need to take 5x minus 1 squared. So 2, 5x minus 1, 5x minus 1, plus 2. Go ahead and multiply these together. 25x squared minus 5x and another minus 5x, that would be minus 10x, plus 1. Now I'm going to bring this plus 2 down, but I don't need to forget to multiply that 2. I'm going to distribute the 2, so that is 50x squared minus 20x plus 2, and then I'm going to bring down the plus 2. So this simplifies to be 50x squared minus 20x plus 4. And that is my f of g of x. The last example we're going to have, and of course you can replay these. I would suggest you do so. The last example we have is find f of g of x and g of f of x for the indicated functions. We have f of x equals 3x minus 3. And g of x equals x plus 3 all over 3. So f of g. I'm going to take my f, 3 times something minus 3, and I'm going to input g of x. X plus 3 divided by 3. Well, perhaps you notice that these 3's are going to cancel, so that this becomes x plus 3 minus 3, which is x. That tells us something very particular, something very special about these two functions. But before I tell you what that is, I'm going to find g of f of x. That means I'm going to take my g function, and I'm going to replace into it f. So that would be something plus 3 all divided by 3. So if I take my f of x and put it in here, that would be 3x minus 3. Well, if I combine like terms in that numerator, I just get 3x. These two form a zero pair. Divided by 3, and then the 3 and the 3 become a 1, so that we arrive at equals x. Because both of these two statements are true, g of f of x and f of g of x are both equal to x, that means that these two functions are inverses of one another. Now, I've used that word before, but inverses means a very particular thing. It'll be very important.